Welcome back to NM Sarena. In this video, we are going to discuss the properties of the measures of dispersion. Dispersion is the variability in the size of items. They tell us the extent to which the values in a series differ between each other or from their average. Now let us discuss the objectives of measuring dispersion. The dispersion tells us how far an average represents the series of data. When the dispersion is small, it means that the average is a typical value in the series. It is a good representative of the data. It is a good estimate of the average in the universe from which the data have been taken. Then it serves as a basis for the control of variability. In order to control the variation or dispersion of a phenomenon, it is necessary to determine the nature and cause of variation. The measurement of inequality in the distribution of maybe income and wealth requires the measures of variation. Similarly, variations in body temperature, blood pressure, etc. are noted for proper diagnosis by the doctor. Then it is also useful to compare two or more series with regard to their variability. The study of dispersion is essential for determining the degree of consistency, uniformity, reliability, etc. A low degree of variation means there is more uniformity, consistency, reliability, etc. for the data, whereas a high degree of variation lacks uniformity, consistency, reliability, etc. So if variation is high, we can say that there is less consistency or less uniformity and less reliability. The next point is to facilitate use of other statistical techniques. So the study of dispersion helps in the application of various other statistical tools like correlation, regression, statistical quality control, etc. Now let us see what are the features of a good measure of dispersion. So when these following features are there, we can say that the measure of dispersion is a good one. The features are: it should be simple to understand, it should be easy to calculate, it should be rigidly defined, and it must be based on each and every item of the series, and that measure of dispersion must have sampling stability, and it should not unduly be affected by the extreme items in the series. If these features are there, that is the best measure of dispersion. Now let us see the different measures of dispersion. The simplest measure of dispersion is range, and it can be easily calculated as we require only two extreme values. If one is interested in getting a quick but not very accurate picture of variability, then he can compute the range. And the range can be used for quality control. Quality control is done to check the quality of the product without 100% inspection. And the range plays an important role when statistical methods of quality control are used. And in preparing our charts, range plays an important role. Thus, range is useful in determining and maintaining the quality of the products. Similarly, range is used in variations, stock and share prices. These variations can be analyzed using range. It is useful in studying the fluctuations in the share prices. By computing range, we can get an idea about the range of fluctuation in the prices of many other items also, like gold, etc. And then range is also used in forecasting, especially the meteorology. Just make use of the range in determining the difference between minimum and maximum temperature, etc. Thus, range is used in preparing information for the layman. Now let us move on to the merits of range. It is the simplest measure of dispersion. It is easy to calculate range and it is easy to understand range. These are the important merits of range. Now regarding the demerits of range, range is not based on all items of the series. Only the extreme values in a series are considered for calculating range. And it is highly affected by sampling fluctuations. It cannot be calculated in the case of open-end distribution. These are the demerits of a range. Now let us understand the merits of a quartile deviation. The first merit is that it is easy to calculate a quartile deviation since it is based on only two values, that is the Q1 and Q3, or the first quartile and the third quartile. It does not involve any much mathematical complications. And quartile deviation makes use of 50% of the data. So it is a better measure than range, which takes into consideration only two items, that is the highest or the largest and the smallest item. The next merit is that it is very simple to understand a quartile deviation. And it is also not affected by the extreme values. Range is influenced by the extreme values, but quartile deviation is not. It can be used in highly skewed distribution where other measures of dispersion do not give reliable results. The quartile deviation is influenced by the position in an array of each item in the series. And in an open-ended distribution, quartile deviation is suitable. It is the quartile deviation which makes the data useful when it is ranked but not measured qualitatively. Now, like the case of beauty, intelligence, taste, etc. In these cases, it is the quartile deviation that is more useful. Now, what are demerits of quartile deviation? The most important demerit is that it ignores the extreme values. It is only based on the Q1 and Q3. So the extreme values are completely ignored. And the quartile deviation ignores 50% of the items, the first 25% and the last 25%. The value of quartile deviation does not depend on each and every item of the series. So it cannot be called a good method of measuring dispersion. An ideal method should be based on each and every item in the series. Another demerit is that it is not capable of more algebraic treatments and it is highly influenced by the fluctuations of sampling. Moreover, quartiles may be same for dissimilar series also. So we cannot use these quartiles for a comparison of series. And it is a measure of partition rather than a measure of dispersion. It is only a positional average. Some statisticians are also of the view that quartile deviation is only a measure of position or a partition. So it cannot be considered as a measure of dispersion. The next measure of dispersion is mean deviation. Now let us analyze the merits of a mean deviation. It is also easy to understand and simple to calculate the mean deviation as it is very close to arithmetic mean. In order to give information to persons having no knowledge of statistics, the measure of mean deviation is more useful. And then it is based on all the items of the series. Any small change in the series would affect the values of the mean deviation. And it is less affected by the extreme items. Then the mean deviation is rigidly defined. It also gives more accurate results. It is a better measure for comparison. Coming to the demerits of mean deviation, it suffers from inaccuracy because the positive or negative signs are ignored. This is not justified mathematically. This limitation makes mean deviation useless for further mathematical and algebraic treatment. Then it is not reliable when it is calculated from mode because quite often the mode is indeterminate or ill-defined. The mean deviation may also be calculated from mode, but it is not reliable. Even the mean deviation calculated from median is not reliable at times. If we use arithmetic mean, then it loses scientific character because the sum of deviations from mean is greater than the sum of deviations from median when plus and minus signs are ignored. And even if when the mean, median and mode are in fractions, then the calculation of mean deviation becomes more complex. So all these are the limitations of mean deviation. And again, there's one more limitation. It is not suitable for calculating mean deviation in the case of open-end classes. Next, let us analyze the merits of standard deviation. It is based on all values in the series. It is a clear and definite measure of dispersion. It is not very much affected by the sampling fluctuations, and standard deviation is capable of further algebraic treatment. Similarly, it has got some demerits like it is a bit difficult to calculate and the extreme items gain great importance. But when all other measures of dispersion are considered, standard deviation is much better than the other measures. So, standard deviation is the best measure of dispersion. Why is standard deviation considered as the best measure of dispersion? The answer to it comes as follows. It is rigidly defined. It is based on all observations of the data. It is capable of more algebraic treatment. It possesses many mathematical properties. It is not much affected by sampling fluctuations. It does not ignore the signs of the deviations. It is possible to find standard deviation of two or more groups, and the coefficient of variation is based on standard deviation, and this coefficient of variation can be used to compare the variability of two series. And the standard deviation is used to find the statistical measures like skewness, correlation, regression equations, etc. So it possesses many of the properties required for a good measure of dispersion. That is why it is considered as the best measure of dispersion. Now let us see how is standard deviation different from mean deviation. In standard deviations, the difference or the deviations are taken only from the mean of the values of the series. But in mean deviation, the deviations can be taken either from mean or from median or from mode. And in standard deviation, the positive and negative signs are not ignored. It is considered. And in mean deviation, the signs are ignored. These are the main differences between mean deviation and standard deviation. So that is all about the measures of dispersion. Thank you for watching the video. For more videos, subscribe the channel.